Hi, this is Jason at MathTutorDVD.com, and today we're going to continue talking about the TI-84, 83, and 84 series calculators. And we're going to, in this particular case, talk about this mode button right here. So we're only going to focus on the mode button today because it really affects how you use the calculator. And this is usually one of the last things people look up in their book, but I'll tell you, there's a lot of settings in here that you can scratch your head over for no reason. We'll just get right to it and learn about it. So you press the mode button and you're presented with a pretty busy looking screen, and that's what really usually turns people off to it. We're going to go line by line and just sort of understand what this is really telling us. At first, let's focus on sort of the first line here and the second line. These kind of work together, so we're going to talk about them together, and then we'll go down the way here. So you can see right now the word normal is blinking, and that means that normal mode is selected. So this is the number mode. It means that the numbers are going to be displayed normally. In other words, they're not going to be displayed in scientific notation, which is the next guy here. And we'll talk about scientific notation in a second. And also underneath it, you see right now it's highlighted the word float. That means floating decimal. So a floating point decimal means that there could be any number of decimals, digits after the decimal point. It just depends on what you're calculating. So with these guys selected here, which are the normal modes of the calculator, let's get out of this menu. You do that by second function and then the quit button here. So you can take 8.2 times 6 and get an answer, and you'll get 49.2, let's say. Now let's say you have something like this, many more decimals multiplied by, let's say, 6.36524. So it's a lengthy little decimal multiplication. You hit enter, and so you see here you get 5564 decimal and then all of these numbers here. So you see in this calculation in the top here we had only one digit after the decimal, and over here we had a whole lot of digits after the decimal. And in both cases we have different amount of digits off in the front, of course, because the multiplication was different. Now let's go into the mode and see what happens. We'll leave the calculator in normal mode, but let's go down to floating point and let's set it up. We'll highlight the number 2 here and go ahead and hit enter. So now you see instead of floating point, it's not highlighted anymore. The number 2 is now blinking, so we'll go ahead and get out of that by second function and quit. And then what we're going to do next is, let's do another crazy multiplication. 87452 decimal 145,879 multiplied by 0.2547, let's say. So a really long bunch of decimals. We'll go ahead and hit enter, and notice what we got. We have some numbers out front, obviously, but after the decimal, we only have 2 digits. Only 2 digits. No matter what you put in this thing, you're always going to get 2 digits after the decimal. And the reason that you're going to only have 2 digits after the decimal is because in our mode menu we told it that we did not want floating point numbers, we wanted 2 digits after the decimal. If you go off here and you set it up to 4 digits after the decimal, you could probably guess that no matter what you do here, you're going to have 4 digits after the decimal. You see, this really could have been 426.5, but it put all the zeros back here because we told the calculator we wanted to have 4 digits after the decimal. So now I think you can understand a little more why they call this floating point or a floating decimal. And that is because when you have this guy selected and you do a bunch of adding or subtracting or dividing or whatever, depending on the numbers you have, you may have 1 digit after the decimal, or 2 or 3 or 4 or 5. It just depends on the numbers that you put in there. And this is the most accurate, obviously having all the decimal places is going to be the most accurate thing. But in many cases you might want to limit the number of decimals just depending on what you're working on. So be careful. If you have this set on anything other than floating point, you need to be aware of that. Okay, up above it here we have normal mode, which is what we're operating in, and here's scientific notation and engineering notation. Now, those of you in science know that scientific notation is when you have when you're trying to represent very large or very small numbers. So it's highlighted here. That means it's selected. Let's go ahead and clear the screen. And let's just put a big number in here. Let's just type a large number like that. And we'll go ahead and hit enter. So the calculator will take that and it's going to spit out the exact same number, but it's going to put it in scientific notation because we told the calculator that everything we put in here, we want it to present answers in terms of scientific notation. So 8.9658 and all this stuff, and then the little e here means multiplied times 10 raised to the power of 11. And that means when you do that, this number times 10 raised to the power of 11 means you basically move the decimal point 11 spots. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have to go 2 more decimal places, 10 and 11, to get to what we have here. And you'll actually notice if you study these numbers enough that I had too many digits in here for this calculator to actually put them on the screen. So it just did the best it could with the number of digits it's allowed to put there. And it sets up the exponent so that if we move that decimal far enough out, then we're going to get a representation of that number. A better example might be if we just type a smaller number in and hit enter, then it's going to represent it as 5.874 times 10 to the 3. We move the decimal 3 places, 1, 2, 3, and then of course we get back what we started with. So that is what scientific notation is. If you put a very small number in here, a number less than 1, and hit enter, you're going to get 2.54 times 10 to the negative 1. So that means I start here at this decimal, I move it to the left, and that's exactly what I input into the calculator. So you'll be using the scientific notation mode quite a bit. Now, it's in scientific notation mode, but you can still set how many digits you want it to have after the decimal. So if we put 4 there and then get out of here, and if we start multiplying numbers together, just do a random multiplication, then the answer it's going to give me is going to have 4 digits after the decimal point, and then of course it's going to have the proper power here to give us the number that we're looking for. So 8.4059 times 10 to the 4th. So basically these modes tell the calculator the accuracy that you care about in your calculation. If you want full up accuracy, then you would just leave it in floating point. You'll get digits all the way across the screen. A lot of times you want to deal in scientific notation in the sciences because the numbers are so big and so small. Now engineering notation, to be honest with you, is a little bit silly. I'm an engineer. And engineering notation isn't really even that useful, but I'll tell you what it is just because it's here. When you put the calculator in engineering notation mode, type a number in here and go ahead and hit enter. It looks just like scientific notation. It's just that the you know, whatever times 10 to the exponent, this exponent here has to be a multiple of 3. So you're only going to see times 10 to the 3, times 10 to the 6, times 10 to the 9, etc. And the same thing on the negative side. So if you put a small decimal in here, something like that, you're only going to see times 10 to the negative 3 or times 10 to the negative 6. And the reason that's done is because a lot of times in engineering you're doing calculations and you want to keep, if you're talking about millimeters, that would be, you know, 10 to the minus 3 meters. Or if you're talking about micrometers, it's 10 to the minus 6 meters. So a lot of times you might want to keep the calculator in a mode to keep the exponents to line up with your units. But you know what, you don't use that all that much. So you know, I wouldn't stress out too much if you don't quite understand that. Scientific notation, normal notation is going to be the bulk of what you're going to use. Now down here below you have a selection between radians and degrees. That's exactly what you might guess. If you put the calculator in degree mode and go ahead and get out of here, then any number that you put in here dealing with an angle is going to be interpreted in degrees. So if you want to take the sine of 90, which you're assuming is in degrees here, and hit enter, you're going to get 1 because sine of 90 degrees is 1. Now if you go back into this mode and change it to radians, which honestly most of the time you will be working in radians in real math and engineering, then if you take the sine of 90, which is exactly what we put in a minute ago, you're going to get a totally different answer because the calculator doesn't think this is 90 degrees you're putting in here. It thinks this is 90 radians. So the equivalent of 90 degrees in radians for those of you who know, is pi over 2. So if we put pi divided by 2 in here, then we should get exactly the same answer. We should get 1 because pi over 2 radians is 90 degrees. So we have the calculator in radian mode. We put this in there, and of course we're going to get the right answer because it knows we're talking about radians. This line here is basically what type of graphs you're going to plot. It's almost always going to be kept in function mode. That's a typical, function from algebra. So that's just a regular algebra functions. This guy over to the right is parametric, and that, if you know what a parametric equation is from algebra, great. That's what you would use for it. If you don't stress out about it. A parametric equation is basically, instead of y being a function of x, you basically say that y is a function of time, t, and x is also a function of time, t. So x and y are functions of something else, time, and you can set your equations up parametrically like that, and you can graph them. Here, if you're plotting a polar equation, you would select this guy, and when you go in the graph editor, you would enter your graphs in polar form. This is if you're going to graph an equation as a function of an angle. And then over here is if you're going to graph a sequence. So a sequence from algebra is this like a sequence of numbers. So it's not going to plot, a continuous function. It's going to plot what the sequence is doing. So 99% of the time, you're going to leave it in function mode unless you're dealing with polar graphs, which is the next most likely thing. These other two things, not going to be used too much. Underneath that is connected or dot. This is basically telling you how it's going to be graphed. If connected is highlighted, which you should always leave it like that, it means that when you go to the graph editor and look at a graph, it's going to be a smooth graph. In between all the points, it's going to connect the dots. If you select dots, then you have the option of basically just plotting the points that you define there and not actually connecting the dots. Okay, and the next one is sequential versus simultaneous is what that's supposed to mean. What this means is also, again, how it graphs something. So let's go in the graph editor. Let's go ahead and clear them out here. If we put down for one graph, let's call it x minus 5, and then in the next one we'll put x plus 2. So we're going to go ahead and put two equations in there and go ahead and graph it, and notice that it's on sequential. So one graph is going to be drawn and then another graph is going to be drawn. That's what sequential means. So let's go back to the mode function and go down to sequential, and let's go graph simultaneous. And what's going to happen at this point, let's go ahead and put a third graph on there just for kicks. We'll put y is equal to negative x, let's say. And let's go back to the graph button. Now all of the graphs are going to be drawn basically at the same time. You see how they're all being drawn at the same time? That's because of this mode that we're in, simultaneous. To me, this is just sort of a personal preference. I always leave it on sequential, really. All right, now under that is very, very important. This is sort of when you start dealing with complex numbers and imaginary numbers. If you know that you're not going to be dealing in any imaginary numbers at all, you can leave the real number highlighted there. Now this guy is if you're going to be dealing with complex numbers in rectangular form. Basically, from your algebra, you should remember there's two ways to represent a complex number. There's rectangular form, which is this, and there's polar form, which is this. So in rectangular form, you have a real part, this little a part, and you have an imaginary part right in front of the eye. And so if I were going to go back to the home screen with that selected, if I wanted to enter an imaginary number, I would say something like 5 plus 2, and then second function, and then this is I down here, so hit this button. 5 plus 2i, and I can enter that into the calculator. And I can add to that, if I wanted to, another imaginary number. Let me take this opportunity to show you another deal. The last answer we put in there was that, so I can hit second function, go down and hit the answer button here. This is going to pull the last answer that I just got, and I'm going to use it in another calculation. So now I'm going to add it to 5 minus 6, second function I. So I'm taking the last answer and I'm adding it to something else. And I hit this button and it adds them together. So it adds the real parts together and it adds the imaginary parts together, and you get the answer, no problem. Now if you go in the mode menu here Let's say you don't want to deal in rectangular representation. In fact, a lot of times in electrical engineering, you don't use this form at all. You use this form, which is exactly the same thing. It's just represented differently. And if this stuff isn't really totally clear to you, it's just something you may not have covered in algebra before. But this is a different way to represent a complex number. So if we go back into the calculator world, and we have selected polar form. Now let's pretend we forgot we did that and type in a complex number, 7 plus 5i. As soon as I hit the enter button, it's going to automatically convert that to polar form because it's operating in polar form because we told it we wanted to operate in polar form. And notice that if you have an answer that kind of goes off the screen, you can just grab your little right-hand arrow key and scroll right through it. So what you have is you have a number out in front of the e. So it's this number times e to the power of, and then this giant number, I. And this is exactly equivalent to 7 plus 5i that we just got. So those are the two different ways of working. It just depends on if you're working in rectangular mode or not. But you know what? If you know you're not dealing with any of that stuff, you could just click it right back in real mode. Now the final thing here is basically talking about how to split your screen. You're almost always going to keep it on full screen. That's what I always do. But occasionally you might want to go to horizontal split, and that's what this means. This means if you click this and make it active, it's going to split your screen. If you go back out here, you're going to have the opportunity to look at the graph at the same time that you can work underneath. So let's say you're looking at a graph and then you're like, oh man, I also need to add 4 times, or 4 times 9 or whatever calculation you're doing. Then you can work down here and you can still look at your graphs. So that's really, really neat. And if you hit the clear button, it clears sort of the basic area of the screen, but your graph is still here. The other nice thing is it lets you go in to the y equals and edit your equations at the same time. So if I say, well, I don't want that, and I don't want this third one here, so I'm going to clear that. I'm going to go up, and I'm going to graph y is equal to, x squared. And so those are the two equations I want. Then I can hit the graph button, and the graph will be redrawn, but I can still see what I'm working on down here. So it's nice. It lets you split it between graph and y equals page, or graph and the regular page where you can add numbers and such. The final thing we're going to talk about on this guy is GT, and that means graph table, graph-table. So let's just go ahead and select it, and then we'll go out of here. And what that means is when I go in and I look at my graph, I'm going to be able to see my graph, but it's going to split the screen so that I can also see a table of values here, which is really useful. And we haven't really talked about this function greatly yet, but suffice to say I've got a plot here, there, and I can go into this table right here, this table set, and basically the table function in the calculator is letting you look at the values rather than just look at a picture of the value. So if I want to say, well, I'm curious what this graph is doing around, x is equal to 10. So I'll put a 10 in here, and we're going to go over this later, but the delta table increment is just basically telling it that I want to start at the number 10 and then go 11, 12, 13, 14. I've got everything else set up on auto, so I'll just hit enter, and then I'll go back to my graph. Right, now you see what happens? I still see the graph that I always have, but x begins at the number 10, 11, 12, 13, 14, and I see the corresponding values of y1. Don't forget, in this example I actually have two equations here, so I can go back and delete this one just to make it a little bit clearer and go back here, and it's just telling me the actual values here. I can go back into table set and say, well, I'm actually more curious about what happens around x is equal to 50. And then I can set that up, hit enter, go back to graph, and then I can see the values around 50, x is equal to 50, y is equal to 2500, x is equal to 51, and y is equal to 2601, etc. And you can get into the table function by itself, but this split screen lets you look at a graph and a table of values at the same time. So that's what it is. And we've covered everything on this screen. I mean, there's a clock set down here. I think you can figure that out for yourself. We basically have number functions up here, how to look at numbers with decimal places, changing the degree function to radians, different kinds of plots here, polar, parametric, sequence, connect the dots or not, sequentially drawn or simultaneously drawn. This is how you represent your complex numbers, and here's how you split the screen. I'm Jason. I hope you've learned something here. Let's go on into the next section. We'll continue learning how to use your calculator.